Every Lambda function comes with a built-in version called latest, and every time you deploy, it gets overwritten. This is actually the default behavior. If you have never published a version, you are running on latest right now. So what happens when someone pushes bad code straight to production? 50,000 requests a day, all hitting broken code. And the worst part, no rollback. Latest was already overwritten. The old code is just gone. There is literally no previous version to go back to. That's the problem. Let us fix it now. The fix starts with versions. When you publish a version, Lambda takes an immutable snapshot, your code, runtime, memory, layers, all frozen. It can never change. Latest still there, it's still mutable, but you published version, it's locked down. See those four properties, frozen, but here's what people miss. Triggers, destination, and provisioned concurrency are still configurable. The code is frozen, the wiring is not. This is important because it means you can attach an SQSQ or change concurrency settings without publishing a new version. Notice the ARN. A published version gets a qualifier, that's 7, at the end. That's how Lambda tells versions apart from latest. You will see this qualifier in every CloudWatch log and X-ray traces. The snapshot mode, just leave it on auto and Lambda will handle it. In practice, almost no one changes that. Now we have versions, but we need a way to point to them. That's what aliases do. An alias is just a named pointer, dev, staging, prod, each pointing to a specific version. Think of it like a DNS record. The name stays the same, but what it resolves to can change. And here's the key insight. Your event source mapped to an alias, not the version. So when you update which version prod points to, every trigger, every queue, every API route wired to that alias follows automatically. No redeployment of your infrastructure needed. The simple rule, use environment names, dev, staging, prod, never per version alias like v7 alias. That defeats the whole purpose. Two strategy for shifting traffic between version. On the left, Canary. You just send 10% of traffic to new version. Then you hold. Watch the metrics. Most teams set this somehow between 5 and 30 minutes, depending on their traffic volume. If everything looks good, full cut over, all traffic on the new version. On the right, linear, a traffic shifts gradually, 10% every 5 minutes, safer for high traffic functions where you want to catch slow burn issue. Each step is a checkpoint. If something breaks at 30%, you haven't lost the other 70. One important constraint. An alias can only point to 2 versions at a time, so you cannot run 3 versions in parallel. It always old plus the new version. And both strategies support auto-rollback through CloudWatch alarms. You define the threshold, Lambda handles the rest. Here's the full code deploy pipeline. Code goes through CI, publishes a new version, then CodeDeploy handles the traffic shift. It runs a pre-traffic hook. Before shifting, this is where you would call a healthy check endpoint or run a quick smoke test, then a post-traffic hook to validate after the shift. If CloudWatch fires an alarm at any point, automatic rollback, no pager, no manual intervention. The whole thing can run while you are asleep. Everything passes, prod alias updates. Let's put it all together with a real deployment. Here's our setup. 3 aliases, dev, staging, prod, all currently pointing to v8. This is your starting state, everything stable. API gateway send production traffic through the prod alias. A developer pushes code, CI/CD runs, and we publish a new version, the v9. First, dev alias swag to v9, smoke test passes, In most teams, this happens automatically. The moment a version is published, dev alias updates the staging, integration test, and it also passes. Now the big one, the production. CodeDeploy kick off a Canary deployment. 90% of traffic stays on V8, just 10% goes to V9. Your user don't notice a thing. CloudWatch is watching. Error rates look flat, so we gradually shift 70-30, 50-50, 20-80. All healthy. V9 takes 100%. Clean promotion, the whole process may be 15 minutes, but it's fully automated. But what if the V8 has a bug? Let's replay that Canary phase. Same setup, 90-10 split. This time, errors start flowing through V9. Only 10% of the user are affected. CloudWatch catches it, error rate spikes past the threshold and alarm fires. Automatic rollback. All traffic back to V8. Zero downtime. 90% of the users never saw the bug. And V9 still exists. It's immutable. You can inspect it, debug it, fix the bug, and publish the V10 and start the cycle again safely. That's the full picture. Dev for fast iteration, staging for safe validation, and prod for zero downtime deploys, immutable versions, named aliases, automatic rollback. That's a production ready Lambda. Versions give you immutability, aliases gives you pointers or named pointers. Traffic shifting gives you safe rollouts, and CodeDeploy ties it all together with an automatic rollback. No more pushes to latest and hoping for the best. Okay, let's start our demo for today. Again, let's do a full recap and then start building. First, when you work with a Lambda function, remember that you have what is called as an alias and what is called as a version. Your alias in this case is just a pointer. It's a name that you give, which point actually into a specific version and configuration at a specific time, and along with that, it also allows you to point this specific version of code and this specific configuration into external services. So services like API Gateway, SQS, Kinesis, and DynamoDB. When you want to point any alias into those services, you will notice at the end of the function ARN that it contains the alias name, right? And the version itself is basically just a snapshot of your code that is mutable, meaning that you cannot edit it, along with few other configurations. So let's now go into the order service that we will create, and let's create a Lambda function. And let's call this order service. And while this is being created, remember that every change that you made it into a version called latest. And this latest is a mutable and overwritable version, meaning that you can edit the code inside of it and you can configure it. And it's changed every time you deploy a new function. So take, for example, the function that we just created in here. Notice that it's just a dummy code. However, when you go to versions, you still don't have any versions. And if you go to alias, there is no aliases. That's because it defaults to the latest, the assigned latest version. Now, if I take the following code, which I copied from my document, and put it in here and deploy it, it just returns a dummy response. And let me just configure this to have a function URL. So go in here, function URL, create a function URL, nothing to change, and save it. Now I get this function URL, and if I go to it, it just returns the response for that code. If I go back to the code and maybe just change a single thing in it, which is healthy, and then put this mark in here and click deploy, and it get deployed. If I revisit the old URL, I can immediately see my changes. which means that any new change that I made in here get automatically deployed into the function URL. Now, if I go into the versions tab and click on publish a new version, it says publish new version from the latest. And publishing a new version save a snapshot of the code and the configuration of the latest version. You need to deploy code changes in latest before you can release a new version, which means that you first need to push your changes and configuration into latest, and from that latest you can extract an immutable version, put it into a new Lambda version. So now if I click on publish, now I am in the version 1. You see in the order service, if I go into versions, now I have version 1. And this version 1, if I go into code and if I try to edit anything in this code, you can get this editor is read only, because this file system of the file is read only. And this is what the immutable means. It means it's not changeable. I can see that I have its own monitoring once it loads. And if I go to configuration, you can see that there are general configurations that basically is also saved with alongside the code. If I go back into the order service, however, and I try to update the code into version 2, like this. So what I did is that I added a feature in here, a feature field, and I incremented the version, and I click deploy. Perfect. Now, if I visit this URL, it's now on the version 2. If I click on versions, I can publish a new version, and we can call it auto increment. So now we have version 2 and we have version 1, and those are immutables. Now, the next thing we need to know is that as we push new features, they get stacked into versions. So we are basically saving them. We are saving the snapshot of how we evolved our code. So if like version 2 has a bug, we can just roll back to version 1 and then push version 3 and go into the version 3. I hope that makes sense. Now, to understand the aliases, that's a different thing. So going back into the original Lambda function, clicking on aliases. Remember, aliases is just a pointers. It points into a specific version of the code, and it also allows you to point your services into a specific alias of the Lambda function. So to understand this, let's create two aliases. One, let's call it dev, and you can see that it needs to point into a version, and let's point it into version 2 and click on save. Now we have the alias dev, and notice the function ARN, how it included the name of the alias at the end. Now if I create another alias and call this one prod, I can point it into version 1 and save. One thing I want you to notice is that each version, or each alias can have its own function URL, and that's perfect. So I'm going to create a function URL for the prod one, and here it is, and I will do the same for the dev one. So in here I'm gonna go to the function URL and create a function URL, and now we got this function URL. It doesn't include anything that says this is the dev alias, basically just a normal URL. And I'm gonna open this again. So now this is the prod one, and this one is the dev one. The dev pointing to v2 and the prod pointing to v1. Dev contain the feature and the v2 version, while the one does not contain the feature field or the updated version. So next, let's see how this can help us in deploying a new version of our code. So we have the version 2 and we have the version 1. Version 2 is dev is pointing into version 2, and version 1 is pointing into prod. I want to deploy a new change, meaning that I want to make sure that I start shifting the traffic for the prod alias, so it go 10% every 5 minutes into version 2, And after 5 minutes, if everything works, it ships the full version into version 2 and it cut on version 1. Again, you use Canary 10% for 5 minutes, percent for the new version, and 90% for the old one, and this goes for 5 minutes. When these 5 minutes complete, if no rollback triggered, it's gonna cut off on the version 1 and shift 100% of the traffic into version 2, which means that we have safely landed on the new version. So to do this, as you can see, we need to use the code deploy. If I go back into my AWS Console and click on code deploy, go to code deploy, I want to go into the applications and I want to click on create application. I have already another one that I did for this demo, but in here we want to say order service Lambda, and you need to select in the compute platform that you are deploying on an AWS Lambda function. You click on create application, and now you have your application. Now you need to create a deployment group, and a deployment group is basically a combination of an IAM or a service role that allows the code deploy to shift the traffic on your Lambda function, and it also tell it which method or deployment settings you want to use to shift the traffic. We said in our Excel draw that we want 10% for 5 minutes. So there is a Lambda Canary 10% 5 minutes, and there's 10% every 1 minute, which means that it ships the traffic 10% every 1 minute. So it goes like 10%, 20%, 30%, and so on until it reaches 100. Let's use this. In the advanced, we're not going to use this, but in the advanced we have triggers and we have alarms. Alarms can be used for rollback, and there is the rollback. We are disabling this, but what basically a rollback does is that when the deployment fail or a threshold are met, the prod will cut on version 2 and switch back into version 1, which means that the version 2 contain some issues. Maybe it's a code, maybe it's wrong logic that triggered alarms. So now you are in a safe hands with all the new features that you deploy. Let's get back into this one, and I'm gonna leave these empty. For this one, I'm gonna call it order SVC Lambda deployment group. And I have already created this IAM for our demo, and I'm gonna click on deployment group. Now the deployment group will be used to deploy our specific Lambda function. And to do this, we can click on create deployment. And in here, what we need to do is first we need to define how we want to do the traffic shifting. So I'm going to use you can either use your function that is, your configuration that lives inside an S3. That's option number 1. Or you can use the app spec editor, which allows you to enter your configurations in line in the editor. So I'm gonna copy my other configurations and paste them in here, and let's just talk about them. This is a standard the AWS structure, so you have to copy it from their documentation. It mentions that you wanna shift traffic for a Lambda function. The Lambda function is called order service. You can verify this by going into here. It's named order service. And then you want to shift traffic for the alias called the prod. And here prod are small cases, but we actually named it upper cases. So let's go in here and say prod. The prod is currently on version 1, which is correct, and we want to ship it into the target version, which means version 2. Okay, remember we did use the Canary 10% for 5 minutes. We can override this per deployment, but let's keep it as it is. And now if I click on create deployment, it's gonna start my deployment very soon. As you can see, 90% of traffic with 10% of traffic. To verify this is working, I can go back in here. I can go back into the prod one, and I can just visit the URL. This is the prod one. I'm getting v1. I'm gonna refresh. I still get the v1, and here we go. After a few refreshes, we are started to seeing v2, which is 10% of traffic. If I refresh, I could get v1 again. Yep, v1, refreshing v2, and so on and so forth. This goes into the alias itself. And to make sure that, to understand how this works, if you go back into your aliases to the prod and you click on edit, you can see in the weighted alias that you actually can go into version 2 and specify the weight of traffic you want. And that's how CodeDeploy does it, but it automated so you don't notice that. Going back into CodeDeploy, this is going to take about 5 minutes to complete. I'm gonna pause and get back to you once it finishes to end the demo there. Okay, now after 5 minutes, you can see the deployment has finished and we are now fully on version 2. And how can I know this? Remember the URL we were visiting? If I refresh again, I am only going to see the new version. No matter how many times we're gonna refresh, we are only going to go with the version 2. And that basically just shows you how a deployment can happen and how Lambda aliases and version can help with this. The last thing is that I want to show you that pointing into that alias is something that you can also do for all of your sources. So right now we just used normal URL invocation. However, in real system there could be like an SQS or something, and for that I created this dummy queue. Going back into my function, going back into aliases. I'm not sure if we can do this directly from here, but I don't think so. So if you say SQS and then you point it to here, you are not able from the UI to directly invoke the queue into the order service alias. But if you go to the alias itself, you can add a trigger, then go to the queue, use that queue and add it. Okay, now it works. This SQS is now a target for the order for the prod alias. If you go back to the original function and you refresh, it's not actually gonna be hooked into an SQS, which means that only this prod alias is where the SQS is actually going to be pointing. One more thing to do in here is, like, if we go into the queue itself, I don't know if this is also going to show in the UI or not. In the Lambda triggers, notice that the ARN is the ARN of the Lambda function alongside with the alias itself. And that's basically how you can hook up a specific alias into your right target. I hope that was clear. The deployment for those targets is very similar to the deployment of these ones. You use the alias itself to change the traffic between v1 and v2. However, the internal invocation of the alias itself does not change. It's what the CodeDeploy works on. So when your queue pointing to prod and there is a traffic shifting in prod from v1 to v2, 10% of the request from the SQS will go to v2 and the 20 will go here, and then after 5 minutes they will be switched. That's how it works. If you have any questions, feel free to leave them in the comment. I hope this has been useful. Thank you for watching and see you in the next video.